Okay. New stream. Let's just make sure things are good. All right. What's going on? Yeah. Okay. So seems like audio is working. All right, welcome back to the Neural Networks from Scratch in Golang tutorial series. I'm wearing the same shirt from the last video. If you're watching this, I don't know, like 5 years in the future, I don't know. But I'm wearing the same shirt because this is in fact the same day. In fact, this is exactly like 10 minutes after the first video, because the first video was, had nothing to do with Golang. So I didn't feel like I wanted to end the day after making the first video in my Golang Neural Networks from Scratch tutorial series without featuring anything from Golang, and so that's why we are doing chapter 2 on the same day. Okay, so finally, so first of all, again, just a brief introduction. I'm going to do this, I think, at the start of every video. What are we doing? We are going through the book called Neural Networks from Scratch in Python. It's a book. We are going through that book, but we're doing it in Golang. Golang is an awesome language, my favorite language. I say it 1,000 times, I'll say it again. And yeah, so we're going through that book, but we're translating everything over to Golang. If you want to buy the book, which I recommend, first of all, there's a link in the description. Second of all, it's actually super easy. Just type in NNFS, Neural Networks from Scratch.io. That will take you straight to their website. Incredible book, super cheap for the value you're getting, especially if you just buy the ebook, which is $30, which is what I did like 2 years ago when it came out. Highly, highly recommend, especially if you code in Python as your main coding language, because it's a book written for Python. Okay, so is that everything that I have to say? Oh, right. This is the second video. If you don't know anything about neural networks, go watch the first video, or better yet, watch someone better than me explain neural networks on YouTube. Second of all, you definitely need to know how to program in Golang. This is not a Golang tutorial in the sense that I'm going to teach you how to code in Go. Not going to happen. Find someone else. There's a link in the description to a very good one, pretty new, was out like a year ago, so very good. Watch that if you don't know how to program in Golang, and then come back here, and we'll love to have you. Other than that, right, link to the book is in the description. Also, one of the authors of the book has a YouTube channel dedicated to tutorials in Python. Highly recommend the YouTube channel. Link to that is in the description. Centdex or Seneddex or something like that. I don't know how to pronounce the name. I'm an idiot. Anyway, okay, chapter 2. Let's get into the meat and potatoes of the video. So coding our first neurons. Here we're going to code our first neurons. And okay, let me just also give you a sense of what's going on over here on this side of the screen. On both sides of the screen. Here we have the book. This is the book. It's an ebook. It's a PDF that I have because I bought the book, and you should do it too. And here on this side of the screen, the right side, this is VS Code, the editor. I have a project open. I called it NNFS. This is where we're going to be doing all the NNFS coding. The way I'm thinking about doing this is that I'm thinking about making every chapter a folder. So this one will be like CHP2 dash, what's this? First underscore, how do you spell neuron? Neurons. In this file will be every coding thing that we do for this chapter. I think this is how we're going to structure it from here until problems emerge, because I imagine we're going to get to a stage where we have code that is going to be used in every single chapter, and so then in like several chapters. So the code that we use in chapter 3 will be used in chapter 4. And so this structure might not be the best, or it might be the best and we just copy everything over every time so that we have a nice system of where everything is. And basically every single folder like this will be its own Golang module. I have never coded in Golang using modules before, like making my code into modules. I've always just sort of structured my files like you would do it in a Python script, in a Python program, because that's where I'm coming from. I'm coming from Python. In this case, however, since I'm thinking that we're going to be coding a lot of very general stuff like matrix manipulation, we're basically going to be making our own NumPy from what I can gather based on the packages I've looked at in Golang. Since we're going to be doing crazy things like that, I think it might be beneficial to make this into a module, into our own module. So every chapter like this every directory like this, and you can imagine we'll have chapter 3, chapter 4, chapter 5 will be its own Golang module, and then when we start coding in that, I'm going to do go mod init, and we're going to knit the modules. Just fair warning, there's going to be like hiccups, because I don't actually know what I'm doing when it comes to modules in Golang, so I'm going to be learning it as we go, essentially. Okay, let's get into the book. So again, we have the directory chapter 2, first neurons, and this is where we're going to be doing all the code for chapter 2. So let's just right now let's do the let's make a main.go. And so here's going to be our main.go file. This is where we will do all of the code for chapter 2. This is going to be our route into chapter 2. And also we should probably new terminal cd into, shoot, now I'm realizing that I should have named this something shorter. Do we even need to do this? You know what? Yeah, I'm just gonna call it chapter 2, and then over here we'll have like a text file, info.txt, and then in the text file we'll put in, let's say like dash first NEURONS, neurons, first neurons, and then we'll put more info in this text file that we need. We might need other stuff, but anyway, I think this might be a better way of doing it. And then also these things will be shorter, so CHP2, and then we'll do go mod init. And I think in Visual Studio Code we don't actually have to pass in the link. I could be wrong. Let's just see. So now we have this go mod thing, and yeah, it makes the link by itself because we're using Visual Studio Code. And I think that this will just do nothing because we don't actually need to tidy anything. But yeah, if we want to add module requirements, we would have to do go mod tidy. Okay, cool. And so good. So package main. This is the main package because yeah, this is the main package. And then func main. Yeah. And then this is, okay, this is a basic Go file, so great. So now we could start taking a look at the book, and then we're going to see what we're going to do. Why did I do this? Because in Python, you just open up a Python file, and you start coding, and that's what he's going to start doing, and I just want to make sure we're set up to start going as well. Okay. While we assume that we are all beyond beginner programmers here, so yeah, I assume that you guys know what you're doing in programming. This is a neural networks from scratch tutorial series, so I'm actually assuming, I'm kind of hoping that you know how to use like TensorFlow even, because like you should, I don't know. But anyway, here we go. We will still try to start slowly and explain things the first time we see them. Excellent, that's good. To begin with, they will be using Python 3.7. And then they say that any Python version of 3+ would likely work. We will also be using NumPy, so it's not from scratch, huh? It's not from scratch. You're using NumPy. NumPy is not scratch. NumPy is crazy. I wish I had a NumPy. After showing the pure Python methods and matplotlib for some visualizations. Oh, they're going to be using matplotlib. Oh, that's interesting. Okay, we need to find a matplotlib library for Golang. Yeah, we're going to need that. Yeah, that's going to be important. Yeah, we're going to need that. It should be the case that a huge variety of versions should work, but you may wish to match ours exactly to rule out any version issues. Specifically, we're using Python 3.75, NumPy, matplotlib. They actually have a whole module called NNFS that they use for like sample data and stuff, which we're gonna have to like try and copy. So that's gonna be interesting. I'm remembering the book now. Okay, since this is a neural networks from scratch in Python book, parentheses with NumPy, we will demonstrate how to do things without NumPy as well, but NumPy is Python's all things number package. Yeah, you're right. Building from scratch is the point of the book, although ignoring NumPy would be a disservice since it's among the most, if not the most important and useful packages for data science in Python. Yeah, I agree. With that. Okay, let's start. A single neuron. Let's say we have a single neuron and there are 3 inputs to this neuron. As in most cases when you initialize parameters in neural networks, our network will have weights initialized randomly and biases set as 0 to start. The weights are random and the bias is set to 0. Yeah, that is in most cases, although sometimes you might want to have a bias not set to 0 because sometimes you'll find that creates a dead network and you don't necessarily want that. But anyway, yeah, he's right. Normally you do start the biases at 0. Why we do this will become apparent later on. The input will be either actual training data or the outputs of neurons from the previous layer in the neural network. So again, any input to a layer in a neural network will either be the actual inputs that you're inputting, let's say pixel values from a picture, or it could be the outputs of a previous layer. If this is a little complicated, go back to the previous video and watch that. And if that doesn't make sense, watch like a general neural networks introduction course on YouTube. I'm sure there's something there. So anyway, yeah. Any input to a neural network layer will any input to a neuron will be either an actual input or previous inputs. Okay, we're just gonna make up values to start with as inputs for now. So okay, let's do this. So he has just a Python list, so we're gonna be doing the equivalent of that. So inputs colon equals, this is Golang. Let's do float 32s. Yeah, that probably makes the best sense. We don't need big floating numbers because big floating numbers in neural networks is actually not desirable, but we do need floats. We're going to need floats. So this is the input 1, 2, 3. Excellent. So those are our inputs. Each input also needs a weight associated with it. Inputs are the data that we pass into the model to get desired outputs, while the weights are the parameters that we'll tune later on to get these results. So again, I'm going to make a quick diagram of a single neuron, and we're going to reference that several times. So okay, we're going to reference this several times, I think. So 1, 2, 3. These will be our inputs, and then we'll have one output, which we will denote as orange, and then every input goes into the output. This will be blue. This is exactly how it was in the previous video. Great. So these are the inputs. The black circles are these. The blue circles are the weights, and then every neuron will have a bias. So let's like draw a bias of some kind, I guess. I don't even know. I guess this could be how we do it. This is a B, right? Yeah, sure. Why not? Let's just say this is a B. So great. So every neuron will also have a bias, and let's just, oh, you know what? Shoot. I'm going to just draw this, actually. Oh, no. Bring the line back. We need the line. Blue line. Marker. Change the color to, like, red. I want a thicker marker. Give me a thick marker. Size. Excellent. Okay, and then every neuron will also have a bias. So this is just one neuron, and you can imagine a layer. Here, I'll make it up. I'll make the imagination of a layer. You can imagine a layer of all these neurons, and every single neuron is connected to every single input in the exact same way as this one is. Everything is connected. And so this one will be connected to this one, and that one, and that one, and that one, and this one would be connected to this one, etc., etc. So for now, we're only concerned with the inputs, and then we're going to get the weights, these weights, the weights for one neuron, and there's going to be a ton of weights, and then also there'll be a bias for each neuron. Okay, so let's get back to the thing, and we can hide this, but I'll probably reference that again. Okay, we'll tune later on to get these. Okay, each input, while the weights are parameters that we'll tune later on to get these results, weights are one of the types of values that change inside a model during the training phase. So you tweak your weights along with the biases during the training phase to get the desired output. The values for weights and biases are what get trained. They're the things that get tweaked. That's how the neural network learns. And they are what make a model actually work. Nice addition there. I appreciate that. Or not work. Actually, maybe I should make this font here bigger. It's possible. Yeah, I think that's better. Yeah, I should. Sorry about that if things were small. But anyway, now they're big. Okay, or not work. We'll start by making up weights for now. I want to make sure you guys can see this well. I feel like that's good. But then we're going to lose space over here. I guess when there will be time. Oh boy, there will be times in this tutorial series where we're going to need to code for like extended periods of time because we're going to have to rewrite a lot of stuff. So when we do that, I'll make this bigger. But when we're looking at the book, I'll make the book bigger. And I'll try to manage things well. I knew this would be a problem managing the book and the coding, but anyway, we're making it work. We're making it happen. Okay, so this is where we're up to. Yeah. The values for the weights and biases are making out. Okay. The values for the weights and biases are what get trained, and they're what make the model work or not work. We'll start by making up weights for now. Let's say the first input at index 0, which has a 1, has a weight of 0.2. And the second input has a weight of 0.8, and the third input has a weight of negative 0.5. So you see how it's denoting that this weight is this input's weight. This weight is this input's weight. This weight is this input's weight. On our diagram, this weight, this thing over here, is this. This input is this. This weight is, this input is this. This weight is this. This weight is this. This input is this. And then we have the bias in the thing, and so on and so forth. And every single neuron will have something exactly like that. And you're going to see how coding things like this is going to get not efficient because the inputs are pretty simple. The inputs are the same for every single neuron. But every single neuron needs its own weights and its own bias. And so we're going to need to do like multiple dimension lists, which are called matrices, which are fun. And so we'll deal with that when the time comes. let's first of all let's make you smaller so I don't have to keep moving things around. And yeah, let's put you over here. Okay, so we need to make our weights. So the inputs are over here. Weights are going to be very similar syntax, but it's just going to be a different name. Weights. I guess that's how you spell weights. And it'll also be a float. Same dimension. Not same dimension. Same size as the inputs because every input gets their own weight. 0.8. And over here, negative 0.5. Excellent. So now we have our inputs and weight. Next, we need a bias. At the moment, we're modeling a single neuron with 3 inputs. Since we're modeling a single neuron, we only have one bias, as there's just one bias value per each neuron. So every neuron gets its own bias, and that's the neuron's bias. That's its bias. That's how it works. The bias is an additional tunable value, but it is not associated with any input in contrast to the weights. So the weights are associated, this weight is this input, this weight is this input, this weight is this input, whereas the bias is just the bias for the neuron. It's not associated to the inputs. As he said. We'll randomly select a value of 2 as the bias for this example. I think biases are always ints, I believe, but are biases always not necessarily? No, not necessarily at all. So we're not going to use the colon equals syntax for our bias float 32 because I want this to be a float 32 as well, and this is the best way I know how to make it a float 32. So again, the bias is this guy, and every neuron has its own bias. Okay. Onward. Okay, so now we get to what a neuron actually does. The neuron sums each input multiplied by that input's weight, then adds the bias. All the neuron does is take the fractions of, wait, hold on. This neuron sums each input multiplied by the weights, by the input's weight, and then adds the bias. All the neuron does is take the fractions of inputs, where these fractions weights, so when he says fractions, I guess it just means weights, are the adjustable parameters, and adds another adjustable parameter, the bias, then outputs the result. Our output will be calculated up to this point like that. So in this particular neuron, we can put in the output like this, although as you can see, a for loop is going to be very useful, because when you have something that looks like that, a for loop is simple, and also summing. Like we're just going to pass that into a sum. But for now, in Golang, this would look like this, out. And so far things look very similar, which is why Golang is amazing, because it looks exactly like Python, and yet it's super fast like C++. And I don't know why more people don't use Golang. Anyway, that's why I'm doing this, because I want everything in machine learning to be transferred from Python to Golang. And I know that's never going to happen, but still, that's what I want. Output colon equals, that's, oh boy, colon equals. Let's make this whole thing big. I hope I'm allowed to do this as syntax. Inputs index 0 times weights index 0 plus I have a shortcut on Visual Studio Code, Control D, that allows me to just duplicate a line. If you don't have that set up, I don't think it comes like that. I don't think VS Code comes like that originally. I think Control D does something else. So you have to go into like your preferences and then find like duplicate line and switch that around. It's very easy. You know what? In fact, I'll just show you how to do it right now. Settings, search like line D, and I'm assuming something will come up. Duplicate line. No, maybe it's like hotkeys. I don't know. Maybe you have to search for hotkeys, or shortcuts or something like that. Shortcuts, something like this. Maybe you have to go into the actual like file. I forget how to do this exactly. Preferences, extensions, keyboard shortcuts. So you have to go to keyboard shortcuts, and then over here, yeah, you find like duplicate section, duplicate, not delete duplicate, but like lines. No, I don't want to delete it. I just want to double it. Here, maybe it's copy line. Copy line down. Yeah, copy line down. So you go over here, you press the edit thing, Control D. 2 existing commands have this key binding. I don't know what the other one is. which, okay, add section to find next. I'm not sure what this is. I've never used this thing, but anyway, copy line down. Sorry, I just want to make sure you guys know how to do that because I find it super useful. And anyway, okay, so plus finally the bias. And there you go. That is our neuron. Now, what's the problem? Expected that, found new line. Yeah, okay, fine. I guess it wants this up here. Okay, and now it's complaining that the output is never used. I like this better. So now, yeah, again, it's just complaining that the output's never used because this is Golang and they don't let you make things without using them. So good. Okay, so now we could do fmt.println, and in VS Code, this imports fmt by automatically output. And just so that I could delete the print statements whenever I want and it won't go away, I'm just going to do a quick println hello. I like doing that at the top of my Go files just so that fmt doesn't go away. I know it's stupid. I know that you shouldn't do it. I don't care. Go run everything and let's see what the output is. There's an error. Why is there an error? 0, 1, 2. Oh, this should not be a 3. This should be a 2. That's weird. I'm an idiot. Oh, it automatically formatted this. But it doesn't look as good. Ugh, very, very unfortunate. It automatically formatted it to make it look good, but it doesn't look good. That's sad. Whatever. 2.30002. 2.3. So why is it 00002? It's because computers don't actually know how to do math. Believe it or not. What are you gonna do? It's just how it is. All right. So anyway, we got the same value that he got essentially. The value here should be 2.3. We'll use blah, 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 to denote output in this book. Yeah, this is the output. Okay, that denotes output. Thank you. And here's exactly his code. This is the code, and then it outputs 2.3. And this is a visualization of how exactly the neuron is doing stuff. In fact, you can watch the, if you buy the book, you can watch the animation, and I recommend buying the book to watch the animation. The animations are super useful. I'm not going to show you the animation here just because I feel like that's not okay. I know I did that one last time, but there are so many animations, and the animations are so, what do you call it, valuable that you really shouldn't have access to it without buying the book. Go buy the book. It's a good book. Anyway, so yeah, so what might we need to change if we have 4 inputs? Let's first run through exactly what we did. Every input was multiplied with its weight, and then that was all of those products were summed up along with the bias, and that's the output for the neuron. That is it. That is how a neuron works. You add up all the inputs times the weight, add the bias, that's your output. It's excellent. It's great. So now let's think about it. What might we need to change if we had 4 inputs rather than 3? Rather than 3 that we've shown so far. So let's see if we can figure out, well, if we have 4 inputs, so if we have like a 4th input denoted by x, what would we need to change here? Well, that input would need its weight, would need a weight, so we'd have to have a new weight. Just show that as w, so we'd have to have a new weight. We wouldn't need a new bias, because every bias is just for its neuron. And then over here, we would need to add another line for this new input and weight, right? That's what we need. That's what we would need to change. So here he's doing that exactly. So he's putting a 2.5 for the new input, 2.5. The weight is going to be 1.0, 1.0. The bias is 2.0, as we've seen before, 2.0. And then this is how it would be depicted. So as you can see, he has his own diagram. These are the weights. And here's the bias, which he has sticking out. It's kind of similar to my diagram. I think my diagram is better, honestly, because it's much more professional. No, it's not. His diagram's better. But anyway, yeah, so here you have the inputs, here you have the weights, and then you have the bias because he has it sticking down because he's a fancy guy, apparently. Okay, fine. Visualizing how the inputs, weights, and biases from the, so watch the animation, all together in the code, including the new input and weight, should produce, so we have the new input, we have the new weight, he put in the new multiplication step, and then the bias is the same. So let's put in the new multiplication step, Control D, 3, and 3. The output that he has is 4.8. Let's run our code. And as we can see over here, 4.8. And this time it's a full 4.8 because now my computer doesn't know how to code. Actually, hold on. I want to see something. Since we did the 2.0, would this now make it a nice 2.3? Nah, it's still the same. All right, fine. Computers don't know how to do math. It's just part of life. So this is the visualization, input, weight, input, weight, input, weight, input, weight, bias, output. Excellent. Okay, now let's talk about a layer of neurons. So instead of having just one neuron, we're going to have 1, 2, 3 now. So this is going to be very fun. Neural networks typically have layers that consist of more than one neuron. Layers are nothing more than groups of neurons. Each neuron in a layer takes exactly the same input. So the inputs are the same for every neuron. That makes sense. The input given to, same exact input, the input given to the layer, which again could either be the training data or the output from a previous layer, but contains its own set of weights and its own bias. So every single neuron has its own weights associated to that input, as you can see. And in fact, maybe there's some way I could visualize this, but I can't because it's confusing and it makes a web thing. As you can see over here, every single input is going to the neuron from its own weight. These orange lines are weights. Honestly, it's an incredible book. You guys should buy the book. Link in the description. Did I say that I'm not sponsored by them in this video? I think I said it in the last video. I'm not sponsored by the people that wrote this book. I just think it's an amazing book. The layer's output is a set of each of these outputs. So now instead of having one output, we would probably have a list. We would have like a, I don't know what you call it in Golang. I call it a list. I just call it a list. I think it might be called like an array. Oh, it's an array. Oh no, it's a slice. In Golang, it's called a slice. So the output now would be a slice instead of a single value, because now we have an output from this one, an output from this one, and an output from this one. Let's say we have a scenario with 3 neurons in a layer and 4 inputs. Okay, so now we're going to rewrite the code. And so now you can really see that things are a little bit crazy. All right, so let's code this in Golang. So inputs are the same, I believe, right? The inputs are exactly the same. So let's separate them, because the inputs will never change, essentially. Now we'll have weight 1. And so all of this is probably going to have to go. Yeah, you're going to have to go. Weights 1 is a list that looks like that. Let's separate weights and bias. Weights 2, weights 3. Because there are 3 sets of weights, and each weight is 4 values. Why are there 3 sets of weights? Well, the reason why there are 3 sets of weights is because each neuron here has its own set. And there are 4 values in each set because there are 4 inputs, and every input needs its own weight. So you can see 3 sets of weights. Each one of them is going to have 4 values. Hope I explained that well. 0.5, oh boy, 0.5, negative 0.91, negative 0.91, 0.26, not negative 0.5, but 0.26. I thought someone was calling me. No one is calling me. And negative 0.5. Negative 0.5. And then over here, negative 0.26, negative 0.26, negative. You know what? I'm just going to copy this, and you guys will have to code it by hand. Oh boy, where'd I go? See, I just switched to the wrong file. That's karma right there. Negative 0.26, negative 0.27, 0.17, and 0.87. And this is going to be weights 1, weights 2, weights 3. So again, 3 sets of weights, each one of them with 4 values corresponding to our 4 inputs. And then of course, one bias. There's always just one, wait, no, sorry. I'm an idiot. There are 3 neurons now. So now we have to have 3 biases. Bias 1, bias 2, and bias 3. 2, 3, and 0.5. 3, and 0.5. I'm such a stupid person. Why are there 3 biases? There are 3 biases because there are 3 neurons, each one of them with its own bias. And now we have to add them all up. So let's do this in a very Golang fashion. I think this is the first step that's going to look very different in Golang versus in Python, because in Python he's just making the list. I think that would be confusing. So let's say outputs colon equals make. We're going to make a new slice. This will be float 32. And how long will this be? How many outputs are we going to have? 3, because there are 3 neurons. And then I want to print out outputs. And now we have to populate outputs. So, and for now, we're not using a for loop. Later we'll use a for loop when we start making things properly, but for now it's just going to look disgusting, as if someone who doesn't know how to coded this. So outputs index 0 equals, and then we're going to have outputs index 1, outputs index 2, outputs index 1, outputs index 2. What is the outputs index 0 going to be? Well, it's going to look exactly like the output that we did last time. Remember, we had one output, so it's going to look exactly the same thing. Inputs index 0 times weights 1 index 0 plus control D, control D, control D, because there's 4 of them. And then I have another hotkey that allows me to multiply my cursor, and mine is set to Alt. I think the default is Alt, but whatever. Alt, it's 1, 2, and then inputs index 3. This is for all the inputs and all the weights. Not O3, that doesn't make sense. I mean, it does make sense, but it's not what we want. Plus bias 1, right? And then it wants the parentheses. So that's our outputs index 0. Now we have outputs index 1 and outputs index 2. So this is going to be the exact same thing, except copy, pasta, weights not 1, but weights 2, and bias 2. Dunk. And then that's going to be the same thing over here, but different. Same thing, but different. Classic. Not 1, but 3 for outputs index 2. Great, and now it's all set up, and now we could print outputs, and he got 4.8, 1.21, and 2.385. Let's see what we get. Probably there's a typo somewhere. 4.8, 1.2, 0.99999. It's annoying how close those are, but they're just not the same. And then 2.385. So yeah, we got it. Oh, this is annoying. I don't like this. I don't like that. No, don't like it. And now he has the structure. So this is what it looks like for him. This is what it looks like for us. As you can see, one issue with Golang compared to Python, Golang tends to take more lines. I agree with that because yeah, Golang takes more lines. Just how it goes. Actually, how many? Oh yeah. The only reason why this is really more lines than his is because we have this broken up like this, and he has it written straight up like that. Is this a picture? Why can't I select things? I guess it is a picture. So outputs is this, which is our thing over here. And then the second output is this thing, which he has over here, and then the third output is this thing. He prints out the outputs, gets the output, we get the same output, and it's great. It's clear, just so that things go a little bit better. I wonder, yeah, it's a little bit annoying that this thing is so far down, like the output comes out so far down. I wish it was higher up. Is there a way I could tweak that? Can I put the terminal somewhere else to make it better? No, it's staying down here. Okay. In this code, so now he's explaining the code, which I feel like I just did. In this code, we have 3 sets of weights and 3 biases, which define 3 neurons. Each neuron is connected to the same inputs. So yeah, each neuron is connected to the same inputs. The difference is the separate weights and bias that each neuron applies to the input. So again, every neuron has its own weights and its own bias. And that's the only difference between each neuron. That's the only way that they're distinct. They all have the same inputs. At this point, we've only shown code for a single layer with very few neurons. Imagine coding many more layers and more neurons. Imagine having to do this for like 1 million neurons. That's never going to work. That's never going to happen. That would take way too long. So this would get very challenging to code using our current methods. You mean the methods that suck? Look like someone who started coding yesterday was coding? No for loops at all. Instead, we could use a loop to scale and handle dynamically sized inputs and layers. We've turned the separate weight variables into a list of weights, so we haven't done that yet, he's turned. We'll do that now. We've turned the separate weight variables into a list of weights, so we can iterate over them, and we changed the code to use loops instead of the hard-coded operations. So yeah, all he's really done is changed the weights into a 2D situation, which we will do. And then over here, he's going to do stuff like that. So yeah, so later we're going to have to really start coding stuff to make it more NumPy-like. But for now, let's just do exactly like he's doing over here. So weights colon equals a list of lists of float 32, and this will have this thing. That's weights 1, and then we'll have this thing. Look how beautiful Golang is. I love it. I used to not like the curly braces. I used to be like, why can't it be like square braces, just like Python? But I actually like the curly braces for lists now. I prefer it. I really like Golang. I'm smitten with it. I really love it. I've been coding in it for like 2 years. I just love it. Okay, great. So now that's our weights, and our biases can be similar. So here, bias is colon equals a list of float 32, and it will be 2. bet it's just faster for me to code it. 3.0 and 0.5. Great, so that's our biases. And we could get rid of those. And now, I guess, yeah, this makes sense. We should keep this, and instead of doing all of this, we will make a for loop to go through it. So his code is Python code, where he's zipping things together and stuff, because he's cheating. We're going to have to figure out how to do this with just straight up Golang. I think we can figure it out. So let's do it. Here we go. I guess we should first loop through every neuron. So how we loop by looping, the way we would loop through every neuron is we would just loop through all the weights, and then we'll get the index value, and that would be corresponding to the bias. So let's do that. For I colon equals range of weights. So that's the index value. Let's say W, or what's the thing that he uses? He uses the thing neuron weights. Oh, and he also changed this to layer outputs. Fine, let's do that. Layer. But we're going to make it Golangy. Instead of having an underscore, we'll just capitalize it. Why is this not working? Great. Layer outputs. You have to go below the for loop, my dear. And instead of being outputs, you're going to be layer outputs. So here we go. So neuron, I don't know how to spell neuron. Neuron underscore weights, colon equals weights index I. So that's the neuron weights. And then neuron underscore, not underscore, no underscores. I got confused. He confused me. He's trying to trick me. Neuron weights. There we go. Golangy. And then neuron just bias is, not just bias, not biases. Bias colon equals biases index I. Yeah, I think this makes sense. Very good. And then we could say for not I, but I guess J colon equals range of neuron weights for every. I mean, instead of neuron weights, let's make it more readable, more understandable in the range of inputs, because we're looping through the inputs really. We want to say, I feel like it's just layer outputs index I equals the sum of all that, right? Yeah, I think that's how it is. No, because we have to sum up all the weights times the. We have to sum up all the weights times the input, but then at the end we have to add the bias. So I think we're going to have to make a variable. Var neuron. I have no idea how to spell this. Neuron. I'm a terrible speller. Neuron output, which would be of type float32. And then so float32, I'm sorry, neuron output plus equals the inputs at index j plus the neuron weights at index j. So this is summing up all the products of the inputs times the weight for this given neuron. And then neuron output plus equals the bias. We're adding the bias, neuron bias. And then we want to say that the layer outputs index I, yeah, the layer outputs index I equals the neuron output. That should work, I believe. fmt.println layer outputs. Let's see if this works. Nope. We'll run. 12, 10.85, 9.51. That is not at all what he got. That's not good. So what are we doing wrong? Let's see. For I range weights. Yeah, we're looping through all the weights. We're getting every single neuron weight. We're getting every single neuron bias. That's good. For J in range inputs, we want the inputs index J plus the neuron weights index J equals 0. I just want to make that 0. The layer outputs index I I don't understand why this is wrong. This should be right. Ooh, that's not good. What are we doing wrong here? Do we have just wrong values? It's possible that he changed the values on me without telling me. No, these are the same values. No, these are the same values. Okay, he's an honest man. He's an honest man. Oh, it's not plus. It's not plus. It's times. It's not plus, it's times. It's just a typo. That's very stupid. 4.8, 1.2, stupid thing that's making me upset, and then 2.385, which is exactly what he got. Excellent. So unlike him, we don't have the zip function, which is a very handy function to have, but we made do with our indexing thing. So like over here, we had to index, whereas he was able to declare it straight up because he has a zip function in Python, which we don't have, which is fine. I'm okay with that. I'm okay with that. I'm okay with that. This does the same thing as before, just in a more dynamic and scalable way. Yeah, it is dynamic and scalable. If you find yourself confused at one of these steps, print out the objects to see. Hey, sorry, I'm live streaming, by the way. So just have that in mind. I'm in the kitchen because the kitchen is comfortable. Okay, so print out the objects of what's happening. I love how he just explained what the print function is. The zip function lets us iterate over, this is just Python stuff. We don't have to discuss this. That's it. How do we know that we have 3 neurons? Why do we have 3? We can tell we have 3 neurons because there are 3 sets of weights and biases. So again, how do you know you have 3 neurons? It's not how many inputs you have. There could be 20 inputs. The way you tell that you have 3 neurons is the amount of sets of weights that you have. So we have 3 sets of weights, and that's how you tell how many neurons there are, because every neuron gets its own set of weights. You also could just see how many biases you have, because every neuron gets its own bias. How do you know? Imagine you didn't look at the inputs. Imagine you couldn't see the inputs, and all you could see is the weights and the biases. How would you tell how many inputs there are? Well, you would look at the size of weights, because every input gets its own weight. So look at how many weights there are in a given set of weights. 1, 2, 3, 4. That means there are 4 inputs, and so we would have 4 inputs. It's very cool. You can combine however many inputs you're given with however many neurons you desire. Again, yeah, you can have like 20 inputs, and you can have just like 2 neurons. But every neuron will have 20 weights. As you progress through the book, you will gain some intuition of how many neurons to try using. I still don't have that. I don't have an intuition of how many neurons to use. We will start by using trivial numbers of neurons to aid in understanding how neural networks work at their core. Trivial, meaning 3 neurons is going to get you nowhere. You're going to need a lot more than that, but that will help you just having, sorry, give me a second, having 3 neurons will just help us understand how it works and stuff. Oop, you're supposed to be collapsed. Okay, onward. Oh boy. Excellent. So, okay. With our above code that uses loops, we could modify our number of inputs or neurons in our layer to be whatever we wanted. We could add a new neuron as simple as adding a new set of weights and a new bias, and our code would handle that because we're using a for loop. Great. To be whatever we wanted, and our loop would handle it. As we said earlier, it would be a disservice not to show NumPy here, since Python alone does not do matrix or tensor or array math very effectively. He says matrix or tensor or array because they basically all mean the same thing. Math very effectively. But first, the reason the most popular deep learning library in Python is called TensorFlow is that it's all about doing operation with tensors. So that's why TensorFlow is called TensorFlow, because it's just flowing tensors. And a tensor is basically like an n-dimensioned list of lists. Okay, here we go. This is going to be your crash course into tensors and vectors and array vectors. How much longer is this chapter? Quite a bit. A layer of neurons with NumPy. So now he's going to start switching things over to NumPy and TensorFlow, which we are going to have to talk about a little bit in depth. But I think actually that this is a good place. I think this is a good place to stop this live stream. We've made it that we're using raw Golang to program a layer of neurons, and in the next one we're going to start going through him turning it into NumPy and understanding what tensors and arrays are. And yeah. yeah, I think that would be a good topic for the next video. Additionally, I have to do some research to find if there is any library in Golang to use for tensors and arrays and stuff like that. So I'll come back with that. If there isn't one, we're going to have to make it ourselves, which will be a thing. So there you go. So this is a good place to stop for this live stream. Hope you guys had a good time. Any questions, comments, concerns, leave it in the comments. Happy to get back. I'll get back to everything, definitely, because there aren't that many comments on these videos anyway. So any comment you have, leave it. Any question you have, leave it. I'll get back to you. Even if it's something as simple as I don't know how to set up Golang in Visual Studio Code, I'll get back to you. I'll link you a video to tell you how to do that probably. So yeah, anyway, hope you had a good time. Yeah, and link to the book is in the description, and I'll see you guys in the next